Hello everyone. In this lecture, we are going to discuss about multiplexer and the different types of multiplexer design. So first, what do you mean by multiplexer? So multiplexer means we are going to combine many number of signals into single signals. Let us take an example. If I am having 5 inputs, I want to transmit this 5 inputs into a larger distance. That is, let's say for example 1 kilometer distance, I want to transmit 5 signals means. Then I need to use 5 different lines for a 1 kilometer distance. Okay, so this will lead to a complex in the logical diagram. So instead of this 5 different lines, I'm going to use as only one line. That is, I'm going to combine all the 5 signals into a single signal. Then, with the help of one control signal, I'm going to select any one of the signal from those 5 signals. Finally, only one data will be sent to the receiver side. So for this purpose only we are going to use for this multiplexer. So multiplexer means we are going to combine many number of signals into single signal. Okay, so we can call this multiplexer as many to one. Otherwise, we can call it as a data selector. Why it is called as a data selector means it is going to select particular data for particular inputs. That is, as I already told, control signal. So control signal is which is used to select particular data. That is why it is called as a data selector. Okay, let's move to the topic. So introduction. So multiplexer, as I already told, is it in a combinational circuit? Yes, that has maximum of 2 power n data. This is 2 power n data inputs and n selection lines and single output line. Okay, that is the block diagram looks like see, these are all inputs. This is 2 power n inputs, and here n selection lines will be there, and this side output will be there. Okay, so this is what a multiplexer block diagram. In the next slides, I will show the pictorial representation. So it consists of inputs, selection lines, as well as output. One of these data inputs will be connected to the output based on the values of selection line. Yes, so this is very important. Based on the selection line inputs, one of the data inputs will be connected to the output. Okay. Since there are n selection lines, there will be 2 power n possible combinations of zeros and ones. Okay, this is 2 power n possible combinations of zeros and ones are there. Let us say, for example, if 2 selection line means, then 2 power 2 possible combinations, that is 4 possible combinations of selection lines are available, right? So each combination will select only one data input. So multiplexer is, we can call it as simply multix. Okay, multiplexer is otherwise called as mux. Okay, right. So there are 3 types of multiplexer we are going to discuss here. That is 2x1 multiplexer, 4x1 multiplexer, and 8x1 multiplexer. Okay. So in 2x1 multiplexer, input is 2 and output is 1. Then how many selection lines are needed here? So for that we are having one formula, that is 2 power n is to 1. Here n is number of selection lines. N is number of selection lines. So in this 2 power n is input. So here input is what? It is a 2x multiplexer. So input is 2 and the output is 1. So input is 2 means, now let's compare these two values. So 2 power n, which is equal to 2, and n is equal to 1. So for 2x1 multiplexer, I am in need of only one selection line. So this is the way to calculate the number of selection lines. Okay. Then 4x1 multiplexer, this is 2 power n is to 1. So 2 power n, which is equal to 4. So n is equal to 2. So 2 selection lines are needed for 4x1 multiplexer. And the 8x1 multiplexer, this 2 power n is to 1. So 2 power n, which is equal to 8. So n is equal to 3. So 3 selection lines are needed for 8x1 multiplexer. Okay, right. So let's 2x1 multiplexer. The introduction, it has 2 data inputs and 1 selection line. Yes, the state of selection line decides which of the inputs propagate to the output. Yes, The truth table of 2 cross 1 marks is given below as it shows. When S is 1, out follows I1, and S is 0, out follows I0. Have a look at this diagram. So this is the block diagram for 2 cross 1 multiplexer. So see how they have drawn the block diagram. Like this, we can draw the circuit that is block. So here I am going to represent I0 and this is I1, and here this is S selection line and this is output Y. And see, here 0 is represented, here 1 is represented. That is, we can give S value as 0 as well as 1. When I am going to give 0, it is going to select this I0 data. So this I0 data will goes to the output when it is 0. When it is 1, this I1 will goes to the output. Okay, so we can create the truth tables like this. That is, when S is equal to 0, here I0 will come. When S is equal to 1, here I1 will come. Otherwise, we can add one more, that is here input. That is input is I am going to give this is I0 and this is I1. When S is 0, this I0 will goes to the output. When S is 1, this I1 will goes to the output. This is the meaning of this truth table. Okay, so let me write the expression for this Y. That is S value is 0, so this is S bar. At the same time, input is I0. So Y is equal to I0 S0 bar plus, and the second combination is I1 S1. So see, Y is equal to S bar into I0 plus S into I1. So no need to go for K-map simplification for this multiplexer. We can write the expression from the truth table itself. So once we have written the expression, then we can draw the logical diagram. See, for this one AND gate is needed, and for this another AND gate is needed. So let me take these inputs like I0 is one line and I1 is another one line. So S is we are in need of two data. One is S, another one is S bar. So like this we can take off 4 lines, and let's take our first AND gate and the second AND gate, and these are added together. Okay, so for the first AND gate, the corresponding inputs are S bar and I0. Where it is S bar, this line is S bar line. So let us take the line here S bar and I0. So here it is I0. So this line. Similarly, the second one is S into I1. So let us take the line here S, and I1 is from here. Okay, then these two outputs are added with one OR gate. So this is the design of 2 cross 1 multiplexer. Okay, right. Next we'll move to the 4 cross 1 multiplexer. So have a look at the diagram. This is the block diagram of 4 cross 1 multiplexer. So 4 indicates number of inputs and 1 indicates outputs. And as per the formula, 2 power n is to 1. So which is 4 is to 1. So 2 power n is equal to 4. So n is equal to 2. So we are in need of 2 selection lines. So those selection lines are S1, S0. Okay, and the 4 inputs are I3, I2, I1, I0. So you can use any variable names, any alphabets here for representing the inputs, and for us output also you can take any alphabet. Okay, right. So it's have 4 inputs and 2 selection line, 1 output, and this is the block diagram of 4 cross 1 multiplexer. Let's go for the design part. So 4 cross 1 multiplexer, we are having 2 selection lines. So those selection lines are S1 and S0. So 2 selection lines means 2 power n possible combinations we can give. So 2 power n means n is equal to 2. So we can give 2 power 2. That is, so 4 possible combinations of inputs we can be able to give here. So those 4 possible combinations are in the proper ascending order: 0, 1, 2, 3. This is a decimal representation. In binary representation, it is 0, 0, 0, 1, 1, 0, 1. Okay, so for these 4 conditions, and the inputs are here, one more column we can add. The inputs are, this is I0, this is I1, this is I0 here, and this is I1, and this is I2, and here I3. So for the first lowest combination 0, 0, the I0 output will comes here, that is the input will comes here, and for 0, 1, I1 will comes here, and 1, 0, I2 will comes here, and 1, 1, I3 will comes here. So we can simply write the expression from the truth table itself. That is, see, S1 is 0 and S0 is 0. So let me write the expression here. So I'm going to write the expression, that is expression y is equal to, so first input is I naught and the selection lines are S0 is 0, so S0 bar, then S1 bar, because S1 value is also 0, and the second combination I1 and S1 is 0, so S1 bar and S0, plus I2, S1 is 1, so S1 and S0 bar, plus I3, S1 is 1 and S0 is 1. Okay, so this is the way to write the expressions from the truth table. So we have constructed the block diagram and we have constructed the truth table, and now expressions also written from the truth table. Now the last step is for 4x1 marks is logical diagram design. So see, so first two lines are taken, that is S1 and S0, that is you can take the lines S1, one line with the one inverter, and S0, one line with the inverter, right? Then 4 inputs, so we can take that input separately. So for the first combination, so we are in need of 4 AND gates. Okay, we are in need of 4 AND gates. So the corresponding inputs we need to take, that is the first one is S0 bar, S1 bar, and the external input I0. Okay, let's take externally I0. Then S1 bar, sorry, here S1 bar, S0, and I1. And the next one is S0 bar, S1, and I2. And the last one is S1, S0, and I3. So we can combine all the 4 outputs into one OR gate as an input. Okay, so now the design was over. So in this similar way, we can design a 8x1 multiplexer also. Have a look at this. 8x1 multiplexer, so 8 inputs and 3 selection lines, 1 output is needed. See, 3 selection lines means it is 2 power 3 possible combinations, so we are going to start from 0, 1, 2, 3, 4, 5, 6, 7. So for each combination, this is I0 and I1 up to I7 will come. Okay, so for each combinations of selection line inputs, the corresponding inputs will goes to the output. So see here, I0 is coming, I1, I2, I3, I4 up to I7. So we can easily write the expressions for this 8x1 mux also, that is y is equal like 4x1 mux. Okay, and we can combine 2 4x1 multiplexer. This is the block diagram design for 8x1 mux. We can combine 2 4x1 multiplexer. See, for the first multiplexer here I0 to I3 inputs are taken. Remaining second multiplexer I4 to I7 is taken. For this is 4x1 mux, so 2 selection lines are needed, and here 2 selection lines are needed. So those 2 selection lines are S1 and S0 is commonly given here. And remaining one more selection line we need to use. So I'm going to take another 2x1 multiplexer. So for this 2x1 multiplexer, I'm going to assign those remaining one selection lines. And these 4x1 multiplexer outputs are given as an input to the 2x1 multiplexer. Finally, they are taking the output. Okay, so this way also we can design 8x1 multiplexer. Okay, and these are all some of the applications where we can use this multiplexer. See, we can use in a player or laptop or satellites, cable TV. Okay, so see, for each device is given as a single input and 2 selection lines we are using, right? So depending upon the selection line, that is when it is 0, 0, MP3 is going to play. When it is 0, 1, laptop is going to play. When it is 1, 0, satellite, and 1, 1, cable TV. So we can use in a different combinations of input this multiplexer as applications. Okay, so I hope you guys are understand the multiplexers and types of multiplexer designs. Thank you everyone. We'll see you in the next lecture.